Hello guys! So it's me, Joyce April Oliva from BS Information Technology 2A. So my topic for today is linear search and algorithm. So first, what is linear search and algorithm? So linear search is a very basic and simple search algorithm. In linear search, we search an element or value in a given array by transversing the array from the starting till the desired element or value is found. A linear search is the most basic type of searching algorithm. A linear search sequentially moves through your collection or data structure, looking for a matching value. In other words, it looks down a list, one item at a time, without jumping. Think of it as a way finding your way in a phone book. So let's start the tutorial. It takes two inputs, one is an array and one is an element. What does it do? It checks whether the element given to the function is present as one of the elements in the array given to the function. So let us see how it goes about doing this. Let's first define the function. So I'm going to have a function search. I'm going to input an integer array. For an example, I'm going to take x as my element. Now, as for the return type, you can either give the return type as Boolean, saying true when the element has been found, and false when the element is not found. Or you can give the return type as integer. What the integer return would be is the index at which the element was found at array. Let's say element x was found at index number 2. We will return to from the function. In case that the element is not found in array, we are going to return it -1. So what is this function going to do? It is going to traverse the array using a counter variable I, and each element of each index of the array, it is going to check if the element in the array is equal to the element we are searching for. So let's take an example. I'm going to display the indexes of the array. Let us say we are searching for x equal to 6, and this is the array we have input. We are going to keep an counter of a variable I. So, in the beginning I is equal to 0, we are going to check if array of I is equal to x. At the moment, x is to 6 and array of I is equal to 8, and so it is not equal in that case. We will go to the next element, that is, we will increment 1. Now, again, we will check this array of I equal to x. 7, is it equal to 6? This is false. So we will go to the next element. We will increment I by 1. Now, 1 is equal to 2. Array of I is equal to 6. X is equal to 6. We check whether array of I is equal to x. This is true, and so at that point, we will return the value of I from the function. So, let's write the code. I started O. I goes up to the last element, or the last index. So less than array dot length. Each time, it increments by 1. At each value of I, what were we checking? We were checking of r of I if that is equal to x. If this is true, we need to return the value of I. If not, we will continue the loop. Now, if my flow of control of the function comes outside the loop, what does this mean? This means that we have checked every element of the array. None of the elements of the array were equal to x. Had any of the elements of the array equal to x, we would have returned from the function, and for the program would not have reached this line. So, when we are outside the loop, we know that every element of the array has failed to equal x. At this point, we will say that x is not found. Since x is not found, we are going to return -1. With this we come to the end of our function. So this is a simple traversal of the array at each time checking whether the element we are searching for is equal to the element in the array. If none of the elements of the array are equal to the element we are searching for, we are going to return -1, indicating that the element is not found. Okay, now that we've seen the code for the linear search algorithm, let us count the number of primitive operations that this algorithm will perform in its worst case. So what is the worst case of this algorithm? The worst case arises when element is not found in the array. So we have already previously discussed how to count the primitive operations, so let's do it for this algorithm. Now, the first statement, which is the for loop. So let's assume that the length of the array is going to be equal to capital N. Now, the initialization of I only happens once, and it takes one primitive operation. The loop runs n times from 0 up to till n minus 1, and so the number of checks made will be for all the n times the loop is entered and for that one extra time. Check fails. Now, we have to calculate the number increments we are going from 0 all the way until n. Therefore, there are n increments being made. Now, we have to check the if statement the number of times. This statement is checked is going to be equal to the number of times. Loop runs. This is because the element x is never found in the array, and so we never return from the function. This statement will occur as many times as it can. So, the loop runs n times, so the if statement will also happen n times. This statement is never executed in the worst case because we are never going to return from inside this statement. This is because x will not be found in the array, so we are not never going to execute this statement. We can leave it now. So, let's go to the next statement, return -1. This will take us 1 unit of time. So, let's see how much the total time taken comes out to be. So, it's 1 plus n plus 1, plus n plus 1. So, this comes out so b. 3n plus 3. When we want to find the big zero notation of linear search, we say that linear search is order n. Why? Because we will do the most dominant term in the time in the worst case, which affects the growth of the algorithm.
I was the knight in shining armor in your movie. Would put your lips on